Hello everyone, welcome back to our math class. Today in this video, we are going to continue our conversation about exponential function. We are going to use exponential function to model some real-life problems, and we are going to use exponential growth and decay to solve some problems. Let's check the first example. First example here, we have the information a piece of land was purchased at a certain amount 10 years ago. The value of the land increased 2.5% annually, and its value was 25,000 now. The question is asking us to find what was the initial value of the land, and the final answer need to be rounded to the nearest cents. So some students probably will notice this time we are actually asking the initial value. So it's a little bit different from the model we worked on before. So this time we are going to kind of going backwards to use the given information to find the initial value. And based on the keywords increase here, we know we are going to use the growth model, which is a times 1 plus r to the t power. So now we are going to plug in the values we know. So this one, 25,000 now, so which means the value after 10 years. So this is considered the final value, which is a y value here. The initial value is one we're looking for, so a will stay unknown, and r is the rate. So as we mentioned before, the rate is oftentimes presented as percentage, but we are going to change it to decimal. Two ways to do that. You can either put in the calculator as 100 divided by 100. You can also move the decimal 2 times to the left and also make up the placeholder for 0 as this. So this one should be 0.025 to the t power here after 10 years. So it's going to be, so it will be 10 to the 10 power. So let's simplify a little bit. This is 1 plus this, so we're going to add it together. So it's 1.025 to the 10 power, and this is this. Since a is multiply the whole thing, so in order to solve for a, we just need to divide by both sides with this, and now we can just find a. So, but one thing to remind you, in this situation, you don't need to do anything like figure out what's the value for the 1.025 to the 10 power. We just need to put everything in the calculator, and it will get 25,000 divided by 1.025 and to the 10th power. So we can find that answer here. And also the answer asking us to round it to the nearest cents, which is 2 digits after the decimal. So this will be our answer. So it's 19529.96. As you can see, the third number is 0. So we're going to get rid of this. We don't need to round it up. This will be the final answer. So that's it. That's how we get. Then we can put a dollar sign. This is the money. And you can see we use a model, but this time since a is one unknown, so we are going to use a little bit extra step to figure out the answer. Okay, we're going to work on the one more example to be familiar with this type of questions here. This situation, Cassie has a credit card, but she forgets to pay, and the company charges 0.3% daily interest. And after 60 days, Cassie needs to pay $1,250. So we're going to ask, how much does she owe at the beginning? So even this is, owing money here, but from the perspective thinking about the value of money, because when you owe the money from the credit card company, if you pay on time, then that's going to be exactly the amount you owe. However, if you do not pay, then the amount is going to be increases on daily basis exponentially. So this scenario actually model that situation. Like we said before, when we say the daily interest is going to be the growth model. So we know it's going to, again, look at this. So now we just need to plug into the value. The y here is 1,250, and a is still an unknown, but this time we are going to use 0.3%. Again, you can just change it to by moving decimal here, 1, 2, and made up 0, so it's going to be 0.003. T is after 6 days, so it's going to be 60, this situation. Now, like we said before, we can simplify a little bit to change it to 0.003 to the 60, and we still have this. Now we just need to solve for A by dividing both sides with 1.03 to 60. So again, we don't need to figure out exactly this value for the denominator. All we need to do is put everything in the calculator and we will find out the answer. So let's do this. It's 1,250 divided by 1.003, but this time is to 60s because we are talking about 60 days. So, and then this. So as you can see, we are going to round it to the nearest cents. So third number is 9. So we're going to round it up. So it's going to be 1,044.37. So as we know here, A is going to be 1,044 point, let's double check again, 37. Okay, and also put a dollar sign here. So as you can see, this example actually a very good example to remind us if you do not pay credit card on time, as you can see, the money increasing very, very quickly. So that's another model we can see when the value increasing exponentially is increased, the speed is actually very fast. You can tell the difference after 60 days, you actually need to pay more than $200. Okay, so this is just a two example to model some situation by using exponential function. I hope this video is helpful. Thank you so much for watching. See you soon, everyone.